Okay, so here we have a variable square minus a constant square. So we have to let that be. So let ax be secant of theta. Okay, but we need to get rid of this b squared, so we have to actually multiply the secant by b. Okay, so let's differentiate this. You get a dx, right, and you get b secant of theta tangent of theta. Okay, so that means here dx is b over a secant of theta tangent of theta d theta. So I'm going to replace that with b over a. I'm going to put at the front. The rest I'm going to put on top. Secant of theta tangent theta d theta. Okay, ax I'm going to replace with. Okay, ax I'm going to replace with b secant of theta. I'm going to square that. So I'm going to get that squared as well as this squared. Okay, so I just replace that with secant minus b squared all to the power of 3 over 2. All right. So we can factor out a b squared. So we have a b squared to the power of 3 over 2. And what's left over inside is secant squared theta minus 1 to the power of 3 over 2. Okay. Now that right there, 2 times 3 over 2 is going to be b cubed. Okay, and then this right here is a tangent. Okay, tangent squared theta. So you raise that to the power of 3 over 2. So this b and this b cubed will cancel, reduce to give you b squared at the bottom. So we have 1 over ab squared. Okay, and this will give you tangent of cubic theta. So we can reduce that to get power of 2 at the bottom. So secant, okay, we have secant theta over tangent square theta. Okay, so it would have been nice if the secant was squared, so that we can let tangent theta equal to u, and then we get a nice simple integration. Okay, but we don't have a square here. So you know what we should do? We should convert this into sine and cosine. So this is going to be 1 over cosine of theta. Okay, that right there is sine over cosine. It's going to be, so it's cosine as a multiplication, right? It's divided by tangent, so as a multiplication, it's going to be cosine squared theta sine squared theta. So we can reduce that. I forgot a square there. So we have cosine of theta over sine squared theta d theta. Okay, now here let's let sine of theta equal to u. Okay, then you get cosine of theta d theta is equal to du. Okay, so that right there is going to be du. Right, so 1 over ab squared integration of a it's going to be du on top here. At the bottom we're going to get just u squared. Okay, so the antiderivative of that is just going to be minus 1 over u. Of course, you gotta change this back into x. Okay, first of all, right, the u I'm gonna replace it with sine of theta. Okay, and going back all the way to the beginning, right here. This means secant of theta is equal to ax over b, which means this. That's a reciprocal of cosine. Okay, so we have hypotenuse is ax, this is b, so we get ax squared minus b squared. Here's my angle theta. So sine of theta is going to be this all over this ax. Okay, so that's it. We just have to replace the sine of theta with that. So we have a 1 over sine. Okay, we have a 1 over sine. So let's put it as a reciprocal. So ax over, so the bottom first and the top on the bottom. Okay, so we have ax over, okay, square root of ax squared minus b squared minus 1 over, so I'm just going to multiply that all in. Minus here ab squared, okay, so plus constant, right? So actually a gets reduced as well. So in the end, we end up with the final answer is minus x over b squared, right? ax squared minus b squared plus some constant.